Assalamu alaikum dear students. How are you all? I hope you all are fine by the grace of Almighty Allah. Welcome back to Higher Mathematics 2 class. In this class I'm going to discuss about chapter 2, linear programming. Linear programming is a mathematical method for determining a way to achieve the best outcome such as maximum profit or lowest cost in a given mathematical model for some list of requirements represented as linear inequalities. লিনিয়ার প্রোগ্রামিং একটা ম্যাথমেটিক্যাল মেথড যার সাহায্যে আমরা ম্যাক্সিমাম প্রফিট অথবা কস্টটা লোয়েস্ট করতে পারবো ইন এ গিভেন ম্যাথমেটিক্যাল মডেল, একটা ম্যাথমেটিক্যাল মডেলের সাহায্যে ফর সাম লিস্ট অফ রিকোয়ারমেন্টস রিপ্রেজেন্টেড অ্যাজ লিনিয়ার ইনইকুয়ালিটিস, যেখানে রিকোয়ারমেন্টের লিস্টগুলো লিনিয়ার ইনইকুয়ালিটিস এর মাধ্যমে রিপ্রেজেন্ট করা হবে। ওকে, standard form of linear programming for two decision variables. It consists of following three parts. First, objective function. In a linear programming problem, there is an linear algebraic expression called objective function. We have to find the maximum or minimum value of this objective function. Okay, and these two variables x and y are known as decision variables of the linear programming. Okay, in a linear programming problem, we have to find the maximum or minimum value of a linear expression, which is called the objective function. This linear expression is called objective function. Okay, part 2, constants or restriction. In a linear programming problem, there is a list of requirements represented as a linear inequalities. These linear inequalities are known as constants. Okay, সীমাবদ্ধতা, শর্তাবলী। ওকে, এবং শেষের যে দুইটা কনস্ট্যান্ট দেখতে পাচ্ছ x greater than 0, y greater than 0, এই দুটো কনস্ট্যান্টস সবগুলো লিনিয়ার প্রোগ্রামিং এ থাকবে। ওকে, x greater than or equal to 0, that means the solution zone lies on the y-axis and left side of the y-axis, and y greater than or equal to 0, that means the solution zone lies x-axis and upper part of the x-axis, and intersection zone of these two inequalities will be the first quadrant of the coordinate system. Okay, that means solution zone of linear programming always lies in the first quadrant. Okay, constraints are the linear equation or inequalities in the linear programming problem. Their solution is graphed as a feasible region, which is a set of points. These points are where the graph of the inequalities are intersects. We have already learned how to draw linear inequalities in the graph paper in my previous lecture of chapter 1. সেখানে আমরা দেখেছি যে ইনইকুয়ালিটিস গুলো যদি সলভ করি তাহলে আমরা একটা জোন পাচ্ছিলাম। এখন এখানে এই কনস্ট্যান্ট গুলোতে যে ইনইকুয়ালিটি দেওয়া আছে সেগুলোকে যদি আমরা সলভ করি তাহলে আমরা যে রিজিয়নটা পাবো সেই রিজিয়নটাকে বলা হবে ফিজিবল রিজিয়ন। ওকে, বা অনুকূল রিজিয়ন। And the largest or smallest value of the objective function can be found at the corner point of the feasible region. The largest or smallest value of the objective function is called optimal value. The collection of values of x and y that gives the optimal value constitute an optimal solution. Now let's see an example. Problem 2 of exercise 2. Solve the following linear programming with the help of graph and maximize each of them. A, z equal to thrice x plus 4y. This is the linear algebraic expression. Therefore, z equal to thrice x plus 4y is the objective function here. of this linear programming problem. We have to maximize this objective function, okay? And constants are x plus y less than or equal to 7, twice x plus 5y less than or equal to 20, x greater than or equal to 0, y greater than or equal to 0. Solution: corresponding linear equation of the given inequalities. First linear equation of the first inequality is x plus y is equal to 7, and solving this we get x by 7 plus y by 7 is equal to 1. Therefore, intersecting point of 1 and x-axis is 7, 0, and it is intersecting point of 1 and y-axis is 0, 7. Similar, solving 2, we get intersecting point of x-axis is 10, 0, and intersecting points of 2 and y-axis is 0, 4. Okay. Now taking x prime and y prime as a x-axis and y-axis respectively. Along x-axis and y-axis, we take length of side of 1 smallest square is equal to 1 unit. এটা ইচ্ছা মতো ধরে নিতে পারো তোমরা, স্কেলিংটা তো অনেক আগে শিখেছো কিভাবে স্কেলিং করতে হয়। To draw the line on the graph paper. X-axis, y-axis, x prime represent x-axis and y prime represent y-axis, and plotting the point 7, 0 and 0, 7, and joining these two we get the line of the linear equation of this inequality. Okay, as this is a linear inequality, that's why solution zone will be upper part of this line or lower part of this line. Now checking by the origin, we get that origin satisfy this inequality, that's why solution zone will be lower part of this line. Okay, now plotting 10, 0 and 0, 4, and joining these two we get the line of the linear equation of this inequality. Okay, and checking by the origin we get that 0, 0 less than or equal to 20, therefore 0 origin satisfy this inequality also, therefore solution zone will be below part of this line. Okay, and x greater than or equal to 0, that means a solution zone will be y-axis and right side of the y-axis, and y greater than or equal to 0, that means solution zone will be on x-axis or upper part of the x-axis. Okay, now intersecting zone of these four inequalities, you get this part. Okay, this region is called feasible region. Okay, Onukul region, and corner point of this feasible region gives the result. Now we get corner points here D04, here O00, A70, and this point. And from the graph we get 1, 2, 3, 4, 5. That means abscissa is 5 of this point, and 1, 2. Ordinate is 2. Therefore, we get from the graph paper this point is 5, 2. Okay. Now, from the graph paper we get 4 points: O00, A70, E52, and D04. Now at 0, 0, z equal to 0, and at 70, z equal to 21, and at 52, z equal to 23, and at 04, z equal to 16. Where z is maximum? Z is maximum at E52. Therefore, optimal solution will be x equal to 5 and y equal to 2, and z max is 23. Clear? I hope it is. Thank you.